Installation. Installation equipment or HVAC system means set up for use, placed in position, or connected to be ready to use. Installation of HVAC equipment becomes as important as any other phase of the industry. Installation covers a broad range of subjects, but one of the most important is the electric circuit servicing the equipment and its wire size. Wire size. The life and safety of the equipment depend on the use of the correct size of wiring. However, the correct wire fuse size is important to the life and efficiency of any equipment. Copper is the most popular conductor in the industry. However, aluminum is used in some cases because of its low cost. So here is a table. We could see the difference between copper and aluminum. Copper is a good conductor, low cost, can easily be joined, bend easily, has good mechanical strength, resists corrosion, and aluminum conduct electricity well enough, but not as good as conductor. Corroded easily, have tendency to become loose because of coefficient of expand. So if we compare these two, copper is better than aluminum. Okay, there are two scales used to measure the size of wire. The first one metric and the other one EWG, American wire gauge. The metric scale is a measurement that indicates the cross-sectional area of the conductor in square millimeters. The AWG system uses a rating number. The larger rating number, the smaller the wire, and the lower its current carrying capability. Most countries use metric scale. Alright, here you could see the difference between AWG and also metric wire size. The AWG, if the number is bigger, the wire size is lower. When the AWG, the number is lower, the wire size is higher. So most of the country use this is metric wire size. A wire may be described in metric size of 5.0, indicating it has a cross-sectional area of 5 millimeters square. It can also be expressed as 10/0.5, indicating 10 strands of wire, each with cross-sectional area of 0.5 millimeters square. The same can be applied to AWG rating 10. And then we have a term of ampacity. Is defined as a maximum amount of electrical current a conductor or device can carry. So this is the meaning of ampacity. The National Electrical Code (NEC) are registered trademark of National Fire Protection Association (NFPA). Govern the type and size of wire that can be used for a particular application and a certain amperes. So in Malaysia we have Suruhanjaya Tenaga that we have to follow. Or somehow they say JKR spec. And then standard wire size is defined in the United States. This book is referred to the books from United by American wire gauge AWG. The list of wire 0000 or 4/0 down to 50, which is the smallest wire. In the industry, wire size from number 20 to number 4/0 are the most common. The most popular size are from number 16 to number 4. Alright, now we see a table of American wire gauge AWG working table from USB row of standard. So here, as you can see, we have the number of AWG start from 000 up to 40, and diameters from in mils 460 mils down to 3.1 mils. This is contradict from the first column to second columns, and then when number of AWG is bigger, then the mil is become less. And this is circular mil cross sections. Later on we'll see how to calculate circular mil. Here is ohms per 100 per 1000 feet at 25 degree. For example, we have 10 AWG. It is 1.2 sorry 1.02 ohm per 1000 feet. Okay, this is the resistance that the wire have if we use a 10 AWG for 1000 feet. Okay, next, this is conductor application and installations. So their short name, this is straight name. For example, here is fluorinated ethylene propylene, or the short name is FEP, FEPB, and the maximum operating temperature this wire could operate up to from 90 degrees, but it's only in dry and damp locations, and it can also operate up to 392 or 200 Celsius in dry location or special locations. This is the thickness of insulations, and perhaps this one is 0.36, and the outer covering is glasses and other suitable bright material, so and so on. Okay, as you can see, this is type of insulator, so it has short name. For example, here RWH and moisture resistant thermostat. It can only use up to 75 degrees Celsius. It can be used in dry and wet locations, and then we see next one. Okay, and they have a lot of it. Let's have a look. TW, the moisture resistant thermoplastic, up to 60 degrees Celsius, dry and wet locations. Flame retardants, moisture resistance thermoplastics. Okay, outer covering tak ada, no outer covering. Alright, okay, this is the rest of the types. Okay, you can have a look in the notes later on. Okay, let's go on the next slide. Okay, in this slide, it shows a table of ampacity of insulated conductor. Means that the amount of current that the wire could sustain. For example, if you find out that the ampacity, the ampere is 30 ampere, so the type of wire should be 10 AWG. If you like to use type TW or UF type, which is could sustain up to 60 degree, or you could use 30. This one is 30 amp. Could sustain up to 90 degrees Celsius, depend on the spec or requirement of the industry. So the type is TBS. So this is 30. Then you could use 12 AWG. Okay, for copper. This one is for copper. Or you could use, if when you calculate that it needs 30 30 amps. Then if you use aluminium, you should use TW or UF, which is 8 EWG for aluminium, or you could use this one. The type is RHW. The size is 10 EWG. Okay. Okay. Example number one. Okay. If 5 tons unit draw 24 amperes, so how to select appropriate wire and which type of wire should we use? So the service technician should add 25 degrees percent of the full load ampacity or ampere range to the total loads, which is 6 ampere. So you times 25% times 24, you get 6. 6 plus 24, you get 30 total ampere that the wire should have is 30. This is safety factor 25%. And then when you look at table 8.3, you could see the circuit would require a copper conductor of number 10 EWG. If you use copper type, you use 10 EWG. If you use aluminium type, then you use 8 EWG. Okay. 24, 30. Okay, 30 for example. This one is already done. Okay, sorry. Okay, 30 degree. So 30 degree, this one you use 10 AWG. If you use a copper, so 30 degree over here you could use 8 AWG. If it does not mention anything about the temperature, so you assume that the temperature should be sustained up to 60 degrees Celsius, which means in Malaysia is good enough, unless you put it near to the hot place. Okay, next example, 5 tons units draw 32 amperes. Okay, so safety factor 25%, times the 32, you got 8 ampere. Then 8 plus 32, you got total 40 ampere. Then you find out in the table what is the size for copper and for aluminium. Okay, 40. Let's have a look. 40, for example here 40, then you could use 8 AWG copper 40, or you could use here no, it doesn't mention anything about the temperature, so as provided we should use a very not too expensive, because when the temperature is high, it means more expensive compared to the 60 degrees Celsius. So then on, if you use aluminiums 40, we use 8 AWG. The type is RHW. Okay, factor to consider in wiring. The first one is voltage drop, must be calculated by insulation technicians. And then this is insulation type, enclosure and safety can be determined using tables. This is 4 factor that one should consider by having having the voltage drop, the ampacity. You could know by having the ampacity, you could know the insulation type, enclosure and safety. But voltage drop, you have to calculate. Alright, voltage drop. In case we read 240 volts at the supply and 210 volts at the equipment when it's operating, then the voltage drop is 30 volts in the circuits. Okay, because then when we minus this, so we got 30. So, and then we have a maximum recommended voltage drop at the branch is 30%, the allowable voltage drop for most manufacturer is 10% below the nameplate rating. So uh, we could only allow up to 10% here, but in Malaysia you have to comply whatever the spec are. Okay, example, we have number 12 AWG wire is run 500 feet, while the voltage drop over a distance. What is the voltage drop over distance when the supply voltage is 240 volts? So TW is a tracer wire used as a dry wire against moisture. Okay, this is side of TW lah yang dalam table atas lah. Alright, let's calculate the voltage drop for this example. Okay, we have 12 AWG run 500 feet. So what are the voltage drops over distance? So first of all, we like to know the resistance that this 12 AWG have from table 8.1. Okay, go 8.1. 12 AWG. Okay, this is 12 AWG. So the resistance that it have for 1000 feet is 1.62 ohm. So for 1000 feet, how much if you like to use only 500 feet? Okay, 162 for 1000 feet. So the ohms for 500 feet is 0.8 ohms. Okay, so you have to calculate it. Okay, and then find the capacity of number 12 AWG wire from table 8.3. Number 12 capacity, the allowable current. 12, the capacity is TW type, right? TW type, the capacity is 25 ampere, right? 25 ampere. That is the allowable ampere that allow. What C is 20. Do I mislook? 12, 25, copper 25, but this is aluminium. Oh, copper. Sorry. It doesn't say use aluminium or copper. I'm not sure this is aluminium copper, but from this case, and it shows that it use aluminium. Okay, assume that this is aluminium, so this wire is aluminium, so the capacity is for 12 is 20, right? 20, this is 25, 20. Yeah, you select the lowest one. So then to find the voltage drop, just time the V equal to IR. This is I we got from the table, and this R we calculate. So we times this is 16 volts is the voltage drops. So we subtract from the supply voltage. 240 minus 16 equal to 225 volts. Right, same goes for these questions. Okay, next example, we have 18 EWG wire run 500 feet. What is voltage drop when the power supply is 210 volts? So we like to know from table 8.1, we find out that the ohms for 1000 feet is equal to 6.51. Okay, number 18. Okay, number 18. So 6.51 per 100 feet. That is table 8.1. So then we look at table 8.3. Okay, 8.3 we would like to find what is the ampacity, the allowable current that can flow inside the wire. So we have 18, the allowable current is only in the table, we have only 14. Okay, types dBs, 14 ampere. So that's it, we have 14 ampere. Now find the ohms for 500 feet. 500 feet, after calculate we got 3.3 ohms. V equal to IR, I times the ohms equal to 46.2 volts. This is voltage total, voltage drop for 500 feet of this wire. If this is drop, how much the current being supplied to the equipment is only 163.8 volts. Okay, this is electrical enclosure. It's a cabinet for electrical and electronic equipment to mount switches, knob, display to prevent electrical shock to equipment user and protect the content from environment like moisture, dust, rain, and explosive fumes. Okay, this is type of enclosure that you have in the market. NEMA 4X, for example, we have provided protection from corrosion, wind blow, dust, rain, spilling waters, hose, collected water, and ice formation on the enclosure, and so on. Right? We have here 1, 2, 3, 5 type of enclosure. All right. I think that's all for this chapter. Thank you.